This is homework set 46 on series. Question 1 asks us to expand this expression here and then simplify it if we can. So I'm going to start at 1 for I and then increment it by 1 to 2 to 3 and then terminate it at 4. Here's what it looks like. Just replace all the i's with a 1. 4 times 1 plus 3 plus, right, the plus is coming from here that says sum. Increment I from 1 to 2. 4 times 2 plus 3 plus 4 times 3 plus 3 and then plus 4 times 4 plus 3. And this is where we stop. I stop at that 4 because the sum goes to 4. It starts at 1, ends at 4. Let's simplify. 4 times 1 is 4. 4 plus 3 is 7. Plus 4 times 2 is 8. 8 plus 3 is 11. Plus 4 times 3 is 12. Plus 3 is 15. Plus 4 times 4 is 16. Plus 3 is 19. Let's add those. When I added them up, I got 52. So I'm going to claim that this is 52. And question 2, we're going to do the same thing, but we got a slightly different expression this time. But I'm going to start now at 2 and end at 5. So let's see what this thing looks like. I'm going to get I, now it starts at 2, 2 squared plus 1. See what I'm doing? I'm taking that I, the initial value, substituting it into I here. All right, and then plus, increment to 3, 3 squared plus 1, plus 4 squared plus 1, plus 5 squared plus 1. So 2 squared plus 1, go left to right. 2 squared is 4, plus 1 is 5, plus there's 9 and 1 is 10, plus 16 and 1 is 17, 25 and 1 is 26, and when I add those up, I'm getting 58. All right, so I'm going to claim now that this is equal to 58. In question 3, we're going to start here at 1 for I and terminate it at 3. So the initial value is 1. Let's write it. Negative 4. Now replace the i's with the 1. Plus, now increment the I by 1. Goes to 2. Plus negative 4. Increment I to 3. And that's where we end. That's the terminal value. So, left to right. Negative 4 to the 1 is negative 4. Plus, negative 4 squared. Negative 4 times negative 4 is positive 16. Plus, now negative 4 cubed is negative 64. So we're going to have negative 4 and 16 is 12, and then minus 64 is going to give us a 52. So let's write 52 in this field for our answer. Question 4, let's expand this expression. Now notice the directions say just expand. It does not say to simplify. So let's just put in, replace I with 2, 3, 4, and then 5. So how about if we start here? Fractions. We'll have x minus, 3i, but I is 2, over x plus 2 times I, and I is 2, right? And that's all to the 2 times I, which is 2. Plus, now let I be 3. We'll have x minus 3 times 3 over x plus 2 times 3, all to the 2 times 3, plus x minus 3 times 4 over x plus 2 times 4, all to the 2 times 4. And finally, x plus 3 times 5 over x minus x plus, oh, I missed a sign there. You probably saw that. Let me just rewrite this term. This is going to be x minus 3 times 5 over x plus 2 times 5, all to the 2 times 5. Now I can fix this up a little bit. How about this? X minus 6 over x plus 4 to the fourth plus x minus 9 over x plus 6, 2 times 3 is 6, plus x minus 12 over x plus 8 to the 8th, plus, and then finally x minus 15 over x plus 10, all to the 10. That's as far as we can go. So this is what I got, and when I compared to the answer in the homework set, the homework actually takes it out one more to x minus 18 over x plus 12 all to the 12th. But that cannot be right, because this is right here, I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5, and this over here would be I equals 6. But you can see up here, things terminate at 5. So I think something's wrong with the answer that's given in the exercise set. Question 5 tells us that we have a pendulum that swings 12 feet left to right on its first swing, and then on each following swing, it goes back to 3/4 of the previous swing. All right, so you've got a pendulum here. Maybe it looks like this. All right, so you let it go here, and what does it do? It comes over here, and it's going 12 feet to the left, all right? So we're going this way, and it goes 12 feet. Then when it comes back, okay, it only goes 3/4 of that, which is going to be 9, and then so on. Now what we're asked to do is just to expand this notation. All right, so how about we're going to go 1 to 4. So how about if we start here? We're going to have 12 times 3/4 to the 1 minus 1 plus 12 3/4 2 minus 1 plus 12 3/4 to the 3 minus 1, and then plus 12 3/4 to the 4 minus 1. Let's fix this up a bit. This is going to be 12 times 3/4 to the 0. We know that'll give us a 1. Plus 12 3/4 to the first plus 12 3/4 to the second plus 12 3/4 cubed. All right, let's expand. This is 12 times 1 plus 12 times 3/4 to the first is 3/4 plus 12 times, how about 9/16 plus 12 times, all right, 3 cubed is 27, 4 cubed is 64. This will give us 12 plus 4 into 12 is 3, so 3 times 3 is 9, plus, now, 12 and 16, okay, 4 will go into each one of those. So 4 will go into 12 3 times, 4 will go into 16 4 times, 3 times 9 is 27, so I'll get 27 over 4, plus now over here, well, 2 divides each, so how about that'll go in 6 times, this will go in 32 times. Well, I didn't see that, so actually 2 will go in again, right? 3 and 16. So 3 times 7 is 81 over 16. Okay, so that's part of it, just to do the expansion. The next part is to actually add them up. Well, you could add these up by getting a common denominator of 16. The LCD is 16, and then go through all that work. But if you don't feel like it, go to Wolfram Alpha and just say evaluate, and then type this in. 12 plus 9 plus 27 over 4 plus 81 over 16, and Wolfram Alpha will return 32.8. All right, so here's what it says, is that this pendulum is swinging left to right, right? You start the swing over here, so you start that swing over here, and it'll keep going like this 3/4 of the time. How far does it go all in all before it stops? Okay, well, what we're saying is that is this in feet? Yeah, the whole thing is going to go 32.8 feet. This is homework set 46 on series. And that closes out homework set 46.